This question is an interesting take on the normal kind of number or algebraic pyramid problem when you start with two bricks and you add them together to get this one and so on up there. So actually we've got a three-dimensional pyramid here. So to help with this, I'm actually going to draw the plan. Well, I'm going to draw the three at the bottom and then the two above. And we're trying to maximize the very top cube. All right, well, here goes. So we know that the sum of the 9 in the bottom is equal to 50, and that's about it. So I'm going to call these A, B, C, D, E, F, G, H, I. And then to get, say, this one here, we would add the 4 that's beneath it. So if I kind of move this here, you can see that it's going to be A, B, D, E are going to give the top left and similar. So let's fill that in. This is going to be A plus B plus D plus E. This one's going to be B plus C plus E plus F, and similar for the other ones. What we notice straight away is that some of them only get counted once, like the ones on the corners, and actually E gets counted 4 times. Because now it comes to finding the top one, and that is going to be these 4 added together. So basically, we're trying to maximize A plus B plus D plus E. I'm just going to add them all together. Okay. Now remember, we know that 9 of them at the bottom add to 50. So why don't I just kind of bring these together? A, B. Do you know what? I don't even need to write that down, do I? I can just replace it by 50. A, B, C, D, E, F, G, H, I. So I'm going to get 50 from this, and I can get rid of all of those. And then what I'm left with B plus D plus F plus H. Those are the ones that are here, so they get counted twice. And I've already encountered them once within the 50, and then E got counted 4 times, one of which is within the 50, so I'm left with 3E. Okay, so this is what I'm trying to maximize. So we want to think about how we can make this as large as possible, and really we want to make the E as large as possible. Okay, and then after that, B, D, F, and H. So they're sort of secondary because I'm timesing E by 3. Right, well remember, 9 numbers at the bottom add to 50. So let's say I was just to add all the numbers from 1 to 9, then that would be a half times 9 times 10, 45. Okay, so that is the smallest that it could be actually on the bottom row. So what I could do is instead of using 9, remember we want to make E as big as possible. So let's replace 9 by the number that's 5 more than it, 14. And that will give me 50. Okay, so let E equal 14. That's going to have a big impact on this sum. So this here will become 3 times 14. It's going to be 42. Right, now what we're left with, actually I probably should have written it in full. Let me do that. Okay, so I've dealt with 14. And after that, I want to make B, D, F, and H as large as possible. So let's make them these. It doesn't matter which is which. This is going to be B plus D plus F plus H. And the other ones that I've only counted once, they can be the smallest ones, 1, 2, 3, and 4. So that's going to be 11, 18, 26. Okay, so the maximum value is going to equal the 15 that we get by adding all of them once, plus 26, which we get by maximizing B, D, F, and H, given that we've already maximized E. And then because we've maximized E, we get 42 from that. Okay, this is a nice question, isn't it? So 50 plus 68 is going to give 118. Brilliant.